Here we will learn, let me delete this, okay. Here we will learn how to repeatedly execute portions of our code in a controlled and precise way by looking at several types of loop in Kotlin. This includes while, do while, and for loops. So in Kotlin we have three loops mainly: while, do while, and for loops. We will also learn about the most appropriate situations in which to use these different types of loops. It's completely reasonable to ask what loops have to do with programming, but they are exactly what the name implies. They are a way of repeating the same part of the code more than once, or looping over the same part of the code, although potentially for a different outcome each time. This can simply mean doing the same thing until the code being looped over, iterated, prompts the loop to end. It could be a predetermined number of iterations as specified by the loop code itself. It might be used until a predetermined situation or condition is met. Or it could be a combination of these things along with if, else, and when loops are part of the Kotlin control flow statements. We will look at all the major types of the loop that Kotlin offers us to control our code, and we will use some of them to implement a working mini application to make sure that we understand them completely. Let's take a look at the first and simplest loop type in Kotlin, which is while loop here. While loops, Kotlin while loops have the simplest syntax. Think back to the if statement for a moment. We could use virtually any combination of operators and variables in the conditional expression of the if statement. If the expression is evaluated to true, then the code in the body of the if block is executed. With the while loop, we also use an expression that can evaluate to true or false. I want to show you an example of while loop. So let's create a var that named assign it to 10 here, and let's create our loop now. While x is greater than 0, then print to log e x equals x equals and dollar sign and x here, and then x minus minus. So the first block of our code is outside of the while loop. So we're assigning integer to x named x is declared and initialized to 10. So we have here a while code. The while loop begins here. It's the conditions if x greater than 0. So while x greater than 0, this code will run. So the codes here you can see here. The first we will print using log.e command to our logcat. But we will do this in user interface as well. So the first time we run our while loop, now x minus minus, as you know, this is the decrement operator. You learned this in previous lectures. So x now 9, 8, 7, and until the while loop x is not greater than 0, the loop will stop and the loop will not work anymore. So I want to show you by live examples. So let me open our Android debug device here, and let's run it. So our program is compiled and it's now installing to our application. Let's open the logcat and press on info. So our code is run here, and lastly in one stopped because the while loop condition is while x greater than 0 is run the code, but if else then don't run the code, then stop the loop. So as you can see here, our loop worked in 9 times. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9 10 times. I'm sorry, 10 times our loop has worked. After last one, the loop is stopped and loop will not work anymore because x is now equals to 0. Because of that, why 0? Because we firstly incremented, firstly we printed our this x to log and then incremented. So after incrementing, we don't printed our x's value. So x actually in x actual value is 0. So let me do one example for clear explanation. I will create a method outside the loop so you can see the final value of x. Final value of x here, and okay, and x. Here you can see, as I said earlier, let me show it is okay. As I said earlier, x final value of 0, but it doesn't print it in while loop because we're printing before subtraction x, and we printed while loop is broken and not working anymore because it's done its job, and here we printing our x final value here. So let's the previous lecture we have I have introduced you the operations and expressions here. We can use expressions in loops as well. So in the same way as the if statement, it's possible that while loop will not execute even once. Take a look these examples here. We can use while expressions in while loop. So for example, we have a name message, for example here, var new messages equals is 3, and var unread messages equals 0, for example. And for example, while new messages is greater than or unread messages is greater than 0, then run this loop, and this will print our messages while this new messages is greater than 0. So of course we can write an AND operator here as well. As I said earlier, this is no you can write any arithmetic you want in the loops, or ands and others. So we have another loop here, do while loop, which is kind of similar to do while loop, but it has more differentiations. The do while loop works in the same way as ordinary while loop, except that the presence of a do block guarantees that the code will execute at least once, even when the condition of the while expression doesn't evaluate to true. For example, var variable, let's declare a new variable. Let's name the variable x and assign it to 10. Do we doing our do while loop now. X plus plus, it is, are we increasing by 1 and printing to log, and do block, in the do block, in the do block, and for example, and x equals to x here. Oops, I forgot the tag here. Oops, the log needs for 23 characters, but I entered 24 characters. And while x is less than 10. So let's run this code and see what this code will give us. This code will give us 11. 1 minute. Yes. So this code has given us 11 because condition is not true, because x is not x. Our condition in while loop is not true because 10 is not greater to 10. 10 is equals to 10, because this normally without do, this code will not run. But with do loop, this code is running because the tradition of the do while loop in Java. This is a least used but sometimes perfect solution for a problem. Even though the condition of the while loop is false, the do block executes its code, increments the x variable to 11, as I said earlier, and prints a message to logcat. The condition of the while loop is x is greater than 10, so the code in the do block is not executed again because the expression is not true anymore. The expression is out of it, wasn't true ever. It false, and it just ran in ones and incremented by 1 to 10 to 11. If the expression in the while condition is true, however, then the loop code in the do block continues to execute as though it was a regular while loop. Now I want to tell about your ranges here. Let's delete our code. In order to continue our discussion on loops, it's necessary to briefly introduce the topic of ranges. Ranges are intimately connected to the Kotlin topic of arrays, which we will discuss later of our video course. What follows is a quick introduction to the ranges to enable us to get us to then go on cover for loops. Take a look at these examples. For example, range of numbers and equals 1.4. What is happening is that we are using the type inference to create a list of values that contains this contains 1, 2, 3, and 4. We can also explicitly declare and initialize range a list as in the following code here. Val uh, range of numbers another equals list of here, and 1 2 3 4 5 1 2 3 4 here. The preceding code uses the list of keyword to explicitly create a list containing the numbers 1 through 4, as we created earlier in this code. How this works under the hood will be explored in the later of our video course in more depth, of course. So then we will see that there is a much more to ranges, arrays, and lists than we have covered here. It's just helpful to have this. I wanted to learn this for quick introduction to complete our discussion of loops by looking at the for loop. Now we are ready to for for loop here, and for loops. To use a for loop, we need a range or list. We can then use a for loop to step through that list and execute some code in each step. For example, let's create a list as we did earlier. Value list here, and 1 to 10 range, and let's for e in the list, and log.e looping plus, so value looping here, value or not value, it's okay, looping current value is omit, let's then delete, we don't need that. Value is e, for example. So let's run our code now. You will see more detail in this example how this works. Okay, our program is run. As you can see here, we had 10 values here from 1 to 10, and we looped each other with this command e in list. So as you can see here, current value is 10, and after that we don't have 10 values because we declared from 1 to 10, and as much as we values we had is all printed to the log with the help of for loop. So in Kotlin, the for loop is extremely flexible and can handle much more than just simple integer values. We will not explore all the options in this lecture because we need to learn more about classes first for your better understanding. We will, however, be returning the for loop in number of places throughout the rest of our video course. So I'm repeating this again. If you have any questions, please ask, and I will answer your question as fast as possible. So now we can go to our controlling loops here. Okay. Controlling loops is important in Kotlin loops, having just discussed all the ways that we can control looping throughout code, it's important to know that sometimes we need to break out of a loop earlier than the condition of the loop specifies. For such occasions, Kotlin has the break keyword. As you can see, break. I want make a break with while, make a code that uses break and while loops in same way. So var count down here, and it's equal to 10, and let's create a while. Our countdown is greater than 0, then if countdown inside our while loop, of course, is equals to 5, then break. Okay, so let's log now. Log.e countdown, and please let's need countdown here. So, and this track countdown minus. Let's run our code now. Our code is running. So as you can see here, the while loop is supposed to show us 10 times because our countdown has 10, but we had added a condition here. If countdown equals to 5, then break the code. As you can see here, we can't see 5 because the countdown was 5, and the breaking he breaked the code, our compiler, of course, and the while loop is no longer running here. So you can see from the presenting output that we countdown equals to 5, and the break statement executes, and execution exits the file a while loop before it gets to print to logcat window, as you can see here. Sometimes you might want to execute only part of the code within a loop, but not stopping loop entirely. For this, Kotlin has the continue keyword, as I want to show you this. Let's okay. Kotlin has continue keyword as continue, as you can see here. So what does this continue keyword do? Let's create an example for you to better understanding. Okay, let's create a var count up equals 0, and while count up is less than 10, count up plus, and if count up is greater than 5, then continue. And let's print log here as well. Every time our code loop runs, log will print to logcat. Log e count down, and the second is count ups. What? Okay. So we now we will create an inside and outside loop, of course, because we have two variables, which is the first is inside, and second the second is outside loop. So you will see why I'm doing this. Log.e outside here and count, oops, count up, and the inside loop, of course, for better understanding, and count up. Oops. Count up. Let's run the code here. Okay. Delete this. As you can see here, in the preceding code, we initialize a variable called count up to 0 here. And we then set up a while loop to keep executing while count up is less than 10 here, as you can see. And inside the while loop, we increase by 1 count up. The next line of code checks to see whether count up is greater than 5, sorry, not 1, is greater than 5, and if it is, the continue statement is executed. The next line of the code prints the value of count up to logcat window. The line of code that prints the value will only execute when count up is 5 or lower, because the continuous statement sends the execution of the app back to the start of the loop. So take a look at the following output to verify this, what's happening. As you can see, 1, 2, 3, 4, 5, oops, and 10. As you can see here, the presenting output that count up is printed while its value is 5 or lower. Once its value exceeds 5, the continue statement prevents the line of code that does the printing from being executed. However, the final code of the code outside the loop prints the value of count up, and you can see that is the value of 10, indicating that the first line of code in the loop, which increments count up, executed continuously throughout the completion of the while loop condition. The break and continue keywords can also be used for loops and do while loops. In this lecture, we used if, else, and when to make decisions with expressions and branch our code. We saw and practiced it with while, for, and do while to repeat parts of our code. Furthermore, we used break for breaking out of a loop before the condition would otherwise allow. And we used continue to conditionally execute only part of the code in a loop. It doesn't matter if you don't remember everything straight away, as we will constantly be using all these techniques and keywords throughout the course. We will also explore a number of more advanced ways to use some of these techniques. In the next lecture, we will take a much closer look at Kotlin functions, which is where all our tests and loops code will go.